is. Why?
Because if the ceiling is too low, then if the destination ceiling is too low, then um,
How
well
low is too
then
low?
if it's below 2,000,
Yep.
then yeah.
Perfect. So if the destination ceiling is below 2,000 feet, it requires an alternate. Okay, good. That's why we need to know what a ceiling is because it just says if the ceiling's below 2,000 feet, right? If we don't know what defines a ceiling, we won't know the answer to does this need an alternate or not. All righty. So, Adam, tell us about your day in Oklahoma City.
Well, hold on one second.
I know what it was like dispatching there.
Did you have any flights that were going here?
No, but I listed Oklahoma City as an alternate, so um, I had a pretty good idea of what was going on.
Yeah. Well, they. Well, no, the big thing was that when I had looked at the METAR earlier today, just because I was sitting, kind of sitting around in class, and I could hear thunder going on outside. So I heard it a couple of times, and anyway, so I'm like, gosh, that's weird. I mean, thunderstorm. I mean, it's not obviously completely unheard of, this time of year. However, it's just more unheard of considering the conditions that were going on outside, as far as, I mean, the temperature was below freezing. There was freezing rain going on. The visibility was down to like a half mile. Anyway, long story short, I kept hearing this. Every time I heard it, I thought it was an airplane. So I'm like, that's weird. And then, anyway, so I looked up the METAR and I saw that it showed that there was thunderstorm and freezing rain at the same time going on. So personally, I have never seen that ever in a METAR. So it was kind of a first for me. Like I said, it's not unheard of because, I know sometimes you hear of like, has anyone ever heard of thunder snow?
Oh, yeah.
Nope.
So, yeah, I mean,
Is that a
it's
thing?
rare. Yeah. Well, it's basically a thunderstorm snowstorm, if that makes sense. It's snowing, but with lightning and thunder. So, how
That
it's usually
would
raining
be
during a
absolutely
thunderstorm.
beautiful.
Yeah, so the precipitation from the snowstorm or from the thunderstorm ends up being snow. So anyway, but in this case it was freezing rain. So it was kind of a really rare thing. But anyway, I looked up the METAR and I sent it to Garrett, and specifically more because of the remarks. I wanted you guys to see the remarks in the METAR to have us go over it in class to take a look at it. And yeah, there it is. So if you guys want to look at that, you're going to see all sorts of interesting remarks in here that are actually, these remarks are actually really helpful for a dispatcher. So is there any volunteers that want to give this METAR a shot? Kind of a test your knowledge, see what you can get out of it.
I'll do it.
All right, go for it.
Okay.
Especially at Oklahoma City Airport, the 22nd day at 16:33 Zulu, wind 010 at 9 knots, 1.5 miles of 1.5 statute miles of visibility, thunderstorms, freezing rain and mist, overcast at 300 feet, -1 degree Celsius, -2 degrees Celsius, dew point. Altimeter 3027, remarks automated weather station, tower visibility is 2, LGT, I'm trying to remember. I can't remember what the LGT or LTG is.
So that's lightning.
Oh, okay. Lightning. Distant? No.
Yep.
Distant.
Distant. I don't know what the ALQ. I've never seen that is. I've never seen that.
That stands for all quadrants.
Okay.
That means, so when you take a look, when you have a METAR, or sorry, I should say a weather reporting station. So when at a weather reporting station, it obviously goes in a 360-degree radius. It's looking north, south, east, and west in all directions, right? And anyway, it basically takes that radius and it puts it into just 4 different quadrants. So you've got like northwest, northeast, southeast, and southwest quadrants. So it's basically telling us that there's distant lightning in every quadrant, all 4 quadrants around the weather station.
Oh, nice. Okay. So all quadrants. Freezing rain below 1,200 feet.
Nope. What does the B stand for?
Oh, sorry. I thought it meant below. No?
Began.
Oh, okay. Freezing rain began at, well, if it began, then that's a time at 12. At 12 o'clock, at 12 Zulu.
1200 Zulu.
1200 Zulu.
No, go back. Hold on a second. So that it does not mean 1200 Zulu. So
12 minutes past.
What it means, it's 12 minutes. So it began at 1612 Zulu. So remember, this METAR is the METAR. So METARs are every hour. Now this is obviously a specie, but it still goes within the hour that it's being issued. So if this was issued at 1633, it's telling us that the freezing rain began at 12 after the hour. So it began at 1612 Zulu.
Oh, okay. So freezing rain began 12 minutes past the hour. Thunderstorms began 25 minutes past the hour. Occasional lightning. I don't know what that whole entire thing means.
It's the sound that lightning makes.
So you've got lightning. So the first thing is obviously lightning. And then the next part is in clouds. Okay, so lightning in clouds is the IC. And then the CC is cloud to cloud. So IC, CC, and then basically the last 2 are basic. Well, the CA, I'm trying to figure out what the CA means.
Cloud to air, cloud to ground.
Cloud to air. Yeah, cloud to ground I knew is the last one. So, yeah, so in clouds and then cloud to cloud, cloud to air, cloud to ground. So basically every type that you can get.
Okay, so lightning in the cloud, cloud to cloud, cloud to the ground, or cloud to the air and cloud to the ground. OHD.
OHD means overhead.
Oh, okay. Oh, that's what I said earlier. I was just like, no, that has to sound wrong. Okay, so I'm trying to write these down. So overhead. And we just said this one. This is at all quadrants. Thunderstorm.
So it's telling us that the lightning that's in the clouds, cloud to cloud, cloud to ground, cloud to air, is overhead and in all quadrants.
Okay, at all quadrants, the thunderstorm. thunderstorm overhead, all quadrants moving northeast. The precipitation is 0.5 degrees or no?
0.05.
So that's the total precipitation in the last hour.
Okay.
So
What would you say, like
0.05
degrees or inches?
No,
Okay.
0.05 inches.
Okay. Precipitation 0.05 inches, and temperature at 1.1 degrees Celsius and temperature is at minus 1.1 degrees Celsius and minus 1.7 degrees Celsius dew point.
Good. Yeah, so a lot of stuff in there, right? Now, almost every one of those remarks is helpful for a dispatcher, you know? So, I mean, you're looking there, so it's telling us, first of all, there, you know, the tower visibility is 2, even though the METAR is showing it as 1.5. Now, the reason why you can get different reports here is because the weather station isn't necessarily located where the tower is. Okay, the weather station might be on the opposite side of the airport, you know, or vice versa. The tower might be on some weird part of the airport as well. So just know that the tower and the weather station aren't necessarily always in the same area. The other thing that, you know, once we start seeing RVR reports in METARs, and I know you've probably seen some already, but when you see RVR in a METAR, you'll always see the visibility. So you'll see the visibility from the actual weather machine, like in this case, it's the 1.5 miles. But then you'll also see an RVR report in there sometimes, and it'll actually say runway 35, RVR 4,000 or whatever. And one thing to remember is that if you see RVR in a METAR, the visibility that you use is the RVR. So one very important thing, and I'm not sure if Garrett, if you guys have been over this yet or talked about this. So if you have, then great. But RVR is always going to be the controlling visibility report. Okay, if it's listed. So if it's not listed, then you don't have to worry about, you know, having it be a controlling factor. But when it is listed, RVR trumps any other visibility reading that you can get. Okay, so if you have, let's say you have a weather report, like, you know, let's say it says 2 miles visibility, but the RVR only says 2,500, then you actually have to take the 2,500, because that's, you know, that's a lot less than 2 miles. So does anybody want to venture a guess as to why RVR is the controlling?
Because it's laser, it's extremely accurate.
Exactly.
And it's right on the runway.
Exactly. And that's the big one. It's on the runway. It is the visibility for the surface that you're going to be landing on. You're not going to land on the tower, obviously. You're not going to land where the METAR weather station is. But yeah, you are going to land on the runway, and that's where the RVR sensors are. They are actually physically right on the runway, shooting the laser up and down the runway. So just so everybody kind of knows, you know, when you start seeing RVR reports in there, that is your controlling visibility. Now, in this case, you have 1.5 miles from the weather station, and then you got the tower visibility that says 2. Now, in this case, you just take the weather station visibility. But the nice part about the information from the tower visibility is that it's telling us that there is a part on the airport that actually has better visibility. So sometimes it kind of gives you a glimmer of hope that maybe your visibility will get better. Not that 1.5 miles is bad, but sometimes you'll see like visibility of less than a quarter mile, but you'll see tower visibility of like 1 mile or 2 miles. And that kind of will tell you that maybe there's a fog bank moving through and the tower has better visibility than where the weather station just happens to be sitting. So the other part about the tower, obviously, is that it's a couple hundred feet up in the air. So sometimes it'll give you an idea of how dense a fog bank might be. Maybe it's only 100 feet, and once you get above that 100 feet, maybe it's clear at that point. So that kind of goes in line with like inversions, right? So, so sometimes that'll give you just a good idea of what kind of fog or what kind of, what kind of obscuration you might be dealing with. So, but yeah, all of that information in this, and that's the reason why I sent it over, is because it's got the tower visibility, you've got lightning distance, all quadrants, freezing rain, thunderstorm, occasional lightning, and then basically there's a ton of little acronym remarks in here. I just kind of wanted you guys to be able to see them all. So,
Okay.
Anyway, I'll shut up for now.
Real quick, can you remind me again what the DSNT stands for again?
Distant.
Oh, distant. Okay.
Yeah, that has the entire legend of definitions right there, acronym.
That's going to be a fun one.
You'd think. It gets worse.
Oh, man.
That's a bad one. But we're still missing some. But, yeah. Yeah, it was pretty crazy. Uh-huh.
So I'm just curious, do some dispatchers, do they, like, when they're working at their desks, do they have like a list of things just in case they forget that they can look at?
Yeah, I have a web page that has only acronyms on it.
Okay. I thought you had to memorize this like forever. You can never look at like any papers, but
Oh, no way, dude. There's way too much information. And the crazy thing is that you're moving through so fast all day that, you may only use a very small portion of the information that's provided to you on one flight, and then the next flight you're using like every single website. You're trying to figure different things out. You're trying to figure out a route. You're trying to work with air traffic control to, like it can change from a super easy flight plan to the next flight being an extremely difficult flight plan to come up with. So it just depends. At any given point, you could, have a worst case scenario, and then the very next flight do a sunny flight from Phoenix to Santa Fe. So it's a rapidly changing environment, and you've got to be nimble on your toes there. Anyways, okay, cool. We are going to have some fun now. So we're going to start off with decoding a couple METARs. I want to make sure that everybody can can decode these. We've gone through the remarks, pretty thoroughly. I don't know, Adam. What do you think? Do you think we should just for today's practice and for the sake of time, should we just have them read up to the remark section?
Well, I'd say, if it's just a short amount of remarks like these ones, I'd say just knock them all out. It only would maybe take an extra 10 seconds.
Okay.
Just to get in the habit of just always looking at them and reading them and repetition. So.
Okay. Alrighty. So let's start at the top of the list here. Everybody's got a mic, right?
Yes.
All right. So we'll start with you, Sierra.
All right. So is this one still in Oklahoma?
Yeah, this is actually Oklahoma currently.
Okay, cool. So it is the 22nd at 23:52 Zulu. We have calm winds, right?
Yep.
Calm winds, at 0 degrees. Does that mean just north?
No,
When it
so
says zero?
when it says calm winds, there's no particular
There's
direction
nothing.
assigned,
Okay.
and there's no not reading, so you just say calm winds.
Okay. And if it
Yep.
says 0, does that mean it's north?
It will, yeah, it
Or
will
just
say.
depending on where you're airplaning?
I believe it says 360 typically.
Oh, okay. All right. And then so we got half statute mile of visibility.
I'll help you out
Okay.
with this one. So this is our
Sorry,
RVR.
I don't think I've seen that before.
Yep.
Okay.
So this is our RVR. When we look at RVR, kind of the key things that are going to stand out to us is first it's going to start with an R and a number. That's our runway number. Okay. Runway 35 RVR is this.
Okay. So
So
runway 35 and runway again.
RVR
40
RVR
RVR
is
is
4,500 feet, varying to
4,500.
5,500 feet.
Okay. All right. And then is FG fog?
Yep.
Hey, pause
Fog.
for a second right there.
Uh-oh.
Uh-oh.
Go back. So this RVR, so this is a good one to use from the thing that I was literally just talking about. So what is our true visibility here then?
4,500 to 5,500?
So
Yeah, so is that better or worse than a half mile than the reading right in front of the RVR?
Better.
Yeah. So this is a case where the RVR is helping us, right? So this is one of the good reasons here why we go with RVR readings, instead of just the actual weather station reading, because in this case, half mile, that's right at our minimums. However, 4,500 to 5,500 feet, that's closer to 1 mile in the RVR range.
Yep.
So that's almost twice as good as the half mile reading. So anyway, just wanted to throw that in.
Okay. So we have a half statute mile of visibility, but on runway 35, correct? We have 4,500 to 5,500 feet of visibility with fog, and then we have our overcast clouds are at 200 feet, and then temperature is 0 degrees, and our dew point is -1 degrees, and then our altimeter is at 30.16, or just 3016, and then remarks are automated at 2. Our sea level pressure is at 225. The 6 is how much precipitation we've had in the last 6 hours. Is that 2?
Yeah. So
2. I can't see past the.
Oops, sorry.
Sorry, I can't see that there. Okay, yeah, 0.22. And then that is the zeros. That is our accurate temperature and dew point. So the temperature is still at 0, and then our dew point is at negative. Is that -6?
-0.6. Yep.
0.6, -0.6. Okay, and then and then I kind of get lost right here at the end. Those last 3 jumbles. So it's your max temperature for 6 hours, and then your minimum temperature for 6 hours, and your pressure. But I couldn't really tell you the right way to read those.
Yep. So the maximum the maximum temperature over the last 6 hours has been 0 degrees. The low for the last 6 hours would be a -1.1 degrees.
Okay.
And then our 24-hour pressure tendency is 6009, and I would need to look up exactly how to interpret this and make sense of it, because that doesn't make sense to me.
So just real quick on that, it's really just the last 3 digits there. So
Okay.
you really 009 has been the change. So if you take like your altimeter, of the current altimeter is 3016. So the 6, I think it means that it rose. I'd have to relook that one back up. But anyway, this, those last 3 aren't really, very dispatch useful, but I think it means that the altimeter went up 009. So, it might have been at 301 or 3007, earlier. You can actually start, if you go back and pull the METAR history, you can actually see what it was. But anyway, I think it just means that it's come up by 009.
Okay.
So
Yeah,
every time you
like
look
I said,
at the number,
I remembered. Sorry, go ahead, Matt.
no, you go ahead. Sorry, finish.
Oh, I was just going to say, I remembered what the numbers were. I just couldn't remember off the top of my head how to read them.
Okay, so the 56009, you're basically reading that as if that's your pressure change from your altimeter.
Yeah.
Okay. Now
Over the last
I get
24
that.
hours.
Okay.
Yep. All right. So because of how fun this specie is, he wants to take a stab at that. Let's go with Greg.
Okay, found my mute button there. So let's see. Oklahoma City, it's on the 22nd, 2327 Zulu. Winds are calm, 1.25 mile visibility. Right, tree 5 right.
Runway
No,
35.
runway. And then the RVR varies between 5,500 and 6,000. And BR is baby rain, right?
Yep.
Broken. Yeah, baby rain at got an overcast at 300 feet, 0 centigrade, 0 C, and then negative 1 degree for the dew point. You have 3016 for the altimeter. You have automated reporting with precip, thunder. Let's see, TWR. I'm pulling a blank for a second here.
Tower.
There you go. Tower visibility 1.5, and the more accurate temperature is a, let's see, it's a +1 and a +6 for the Celsius, and for the temp, and the 6 for the dew point. Oh,
So-
negative. Oh, negative. Yeah, negative because of the 1. That's right. So -6
Nope. -0.6.
points. That's why it was throwing me off for a second. I saw so many zeros.
Yeah.
So
So
0.6.
put
That's
our-
0.01 then, right?
Nope.
Just
Nope. So the 1 indicates a negative, right? So we look at this part in a 4 numeral section. Our temperature is going to be the first 4 numbers, and our dew point is going to be the last 4 numbers. The first space is for indicating whether it's a positive temperature reading or a negative temperature reading. So for a positive temperature reading, we'll see a 0. For a negative, we'll see a 1. This is our tens place, ones place, and then our 0.10s place. So
that threw me off a little bit looking above. It had 00, so I guess I should have known that's a fraction of a degree.
yeah, so like I was saying yesterday, sometimes the easiest way, if I get lost on this part, every time I see this T part, I always look up here and I just make sense of it with that. because they're going to be pretty close to each other. Cool. So that being said, which visibility are we going to use, and what is that visibility?
Well, the 5500 is it's about 1.25 miles, so it's pretty close to 1.25.
Mhm.
So I'd say it's about the same, isn't it?
Yep.
6,000's a little better, but so I guess take that.
Yeah. So we'll have to use the most penalizing of the RVRs.
So,
So
55.
RVR, yeah, we can't. When we're looking at this, we're not going to choose which one best suits our needs, right? We're going to go RVR is controlling. Whenever we see an RVR value, we're going to go with the lowest reporting RVR.
So 5280 is a mile, so that's a little better than a mile.
Yep. So that's our RVR. Now, just to kind of make sense of why RVR is controlling, let's go to a chart really quick. Let's go to Oklahoma City, since this is where the METAR's for. Okay, we've got an approach 3.5 right? Okay, when we're looking at this approach plate, we're going to come down here to the bottom. So if you look right here, so first of all, what are our landing minimums?
So I have, so the 1/2 mile, 200.5, basically.
Okay, yeah, so we've got 200.5, but since our RVR is controlling, if we have 1800 RVR, then that's what's controlling. 1800 RVR equals a little less than 1/2, right?
Yeah, that's even better than 2,500 feet. So
Yep. So there you go. Our RVR, all we have to have, if our RVR is reporting and we're using the METAR to derive our legal to go, like I don't want to confuse you guys, but
Hold on, yeah. So if it says if our RVR on our METAR gives us like on my last one where it said like 45 to 55 on it, and then this comes back and says like 18 or something, which one do we use?
so our METARs are forecast, right? That's what's currently happening at the airport. So that's telling us what's happening at the airport. What this approach plate is telling us is what do we have to see in that forecast in order to be in order to use this approach. So as long as everything's working at the at this runway, at this airport, using this runway, as long as we have the ILS, as long as we have our glide slope, the localizer, and all of our lighting system, we can use 1800 RVR. And like I said before,
regardless of
that's below 1/2 mile. So
the METAR is just, just giving you the forecast for applying it to the qualifying 1800.
Mm-hmm. You confused?
Little bit. I just like if you click back over on the METAR and it gives us our RVR there, you said if we have that RVR, then that's what we're gonna use is this 55 to 60. So where does the 18 come in?
Yeah. So this is our forecast once again. So our forecast is, are we legal to dispatch this flight? Okay. We're looking at legal. Now, this isn't something that we're going to teach in this class necessarily, are we? Where if the flight is under an hour, so legal to go. Okay.
So the reason why you went to that is because I have 1.25 miles, in this case, 5,500. So you're going to go check because, they might not have a runway that is suitable. So then I'm looking at the 1800 and saying, hey, I've got less than a half a mile. I'm good.
Well, okay, so when we're looking at legal to go, okay, if the flight, now this isn't something I want you guys to write down. This is like dispatch when you get to the job. But let's take SkyWest for instance. If the ETA is less than an hour, so it takes us less than an hour to get to our airport. We have to use the METAR. We have to consider the METAR for legal to go. Okay. When we look at this METAR, if I see 1 1/4, that, like we said yesterday, that's going to bring up a concern to me as a dispatcher. Do I have an approach? At that point, do I have an approach that will allow me, like,
Oh, that's right.
okay,
Because it's under 2, so you have to check the approach plate.
right. So I'm going to come here
That's
to the
right.
approach plate and I'm going to go, what are my landing minimums? I have to have,
And it
and when we're looking at legal to go, we don't care so much about the ceiling. All we care about is our visibility. Do I have a half mile? And let's go back over here. Okay. If this, say that this one's not there, say the one's not there at all, and it's just a 1/4 mile.
then it's a no-go.
Well, hold on. So it's reporting a 1/4 mile at that point, but it's also reporting an RVR of 5,500. RVR is controlling, right?
Yes.
And I come to this chart and I see that I have to have a half mile visibility. Oh, wait, it's telling me that I can use my RVR. And if I see RVR 1800 on that METAR, RVR is controlling. I'm now legal to dispatch that flight.
Because it's over the 18.
Because it's over the
It's at
1800 feet.
55 and 16. Oh, okay. Okay. Thank you for explaining it like that. That makes it makes sense now. Okay.
So I don't want you guys to remember the whole ETA thing that I just said as far as like if it's less than a net. We're not going to focus on that right now. What I want you guys to focus on is this RVR is controlling. So if my visibility is just reporting a 1/4 mile like that, but I'm also reporting an RVR value, then I'm going to check my chart and see if my RVR value allows me to dispatch the flight. Gosh, I got to close some of these down.
So the RVR will always dominate, and as long as it's over whatever that RVR in that box says, then we're good.
Yep.
Okay.
So that was fun.
I get it.
That was a good
now.
one. That was a good one to talk about. I'm going to put my one back. Okay.
So before you move forward, I was kind of stumbling because I was looking at something else above when you called on me, but so let's visit that one. Wait, where'd it go? You jumped. Let's see. Yikes, the ice can. All right, above. So after the automated reporting 02, it has SFC. Is that something funnel cloud or what is that?
This one right here?
Yeah.
Surface visibility.
Surface.
Mm-hmm. So this is just saying at the surface.
Just a predicator to the visibility. Okay.
Yeah. That's just saying that at the surface I have 1 mile of visibility. Now you can see here, this one is a good example, right? Half mile visibility. We've got an RVR reporting. This is kind of telling us, hey, heads up, we might have the necessary visibility here. But I also have an RVR. We don't care about this. We can't derive legal to go off of anything in this remarks section. So surface visibility, tower visibility, just it's more of like a gee golly. It doesn't mean anything to us as dispatchers because we can't use that to derive our minimums. Okay. What we can use though is either this visibility or our RVR. If our RVR is reporting, we have to use our RVR. And not only do we have to use our RVR, we have to use the lowest reporting RVR. So forget about this. Forget about this. If you see an RVR report, that is your visibility at the airport. Does that make sense?
Yeah, perfect. I was just stumped on that. I don't know why I wasn't attaching that SFC to the visibility. I was reading it as a separate. So I was off looking it up, trying to figure it out when you called on me.
Yeah, no problem.
I'm with you now.
So let's look at this. If if I saw that, like, let's change up this. If I saw this and I looked at my chart, quarter mile, we're automatically going, you know what, that's lower than any ILS approach will ever give you. The absolute lowest that you can ever shoot or derive your landing minimums from would be a half mile. So 200 and a half is the absolute lowest minimum landing minimums that we can ever use, right? But lucky for us, we have an RVR reporting. RVR is controlling. So at that point, we go and we check this chart. Boom, we have on our chart, it says we can either use a half mile visibility, but if our RVR is reporting, we can use RVR 18. So we go back to the chart, or to our METAR. Our RVR is over 1,800 feet. Winner, winner, chicken dinner. We're legal to go. Make sense? Everybody good on that?
So prior to your explanation, I would have taken the 2,000 and said, look, that's even below a half. But you're saying it doesn't really matter. You just, if it reports an RVR, I go look. If I can find one under a half, I'm good.
Yep. Don't convert your RVRs to distances necessarily. You want to take RVRs for face value. The only time, well, I'm not even going to bring it up. Okay. Take RVR for face value. If our chart reports an RVR, that's what we use. So as long as this approach is an approach we can use, our landing minimums are 200 and a half, or the RVR is reporting. If the RVR is reporting and it's, if the METAR is applicable and the RVR is reporting, we can use the 1,800 RVR. Don't get confused on that. Just RVR's face value. Boom. We're good to go. Oh, man. It gets so confusing, doesn't it? I feel bad. Okay. Let's speed up these METARs here. Who wants the next METAR?
Can you hear me?
I can.
Okay. I was having problems with my mic. I'm sorry.
No, you're good. All right, Yvonne. Why don't you give us that one?
I'm not sure what airport KBNA is.
It's a Banana Airport.
Okay.
No, I'm just teasing. It's not Banana Airport.
I don't know if it's Arkansas. I mean.
Nope. It's oh boy. I just gapped
All
it.
I know is it's in California. It's in California.
Nope, it's not in California.
Huh?
Nope.
What? Oh.
No, this one's is it
Nashville.
Yeah, Nashville. That's what I was
Nashville.
trying to say. TYS is Tennessee. No, TYS.
TYS is Knoxville.
There we go. Listen to Adam. I learned all my
They're both
airport
in Tennessee.
dumped them out.
Right on.
Nashville on the
I know
22nd.
any city code. You leave the city codes to me.
Okay. On the 22nd of this month at 23:53 Zulu, calm winds, 0 knots, 1.5 statute mile, runway 02 left. Precipitation,
Nope. What does the P always mean in a METAR?
well, I know it's not
I just changed it for you.
positive, thank you.
Yep.
Positive 6,000 feet,
So greater than 6,000 feet.
greater than 6,000 feet, mist, overcast 400 feet, 15 degrees Celsius, 14 degrees precipitation, altimeter reading 30.31. Remarks are automated. SFC, I'm not sure of.
Surface.
Surface visibility 2, sea level pressure 264. Precipitation
Over the last how many hours?
6 hours.
Uh-huh.
And our hourly temperature and dew point.
So this is just an accurate temperature dew point spread, right?
Correct.
We can see that up here and figure out what these are.
And I know we've been going over these last 3 sets. It has to do with time and temperature.
Nope. Highest temperature over the last 6 hours, lowest temperature over the last 6 hours, and pressure tendency over the last 24.
Thank you.
Yeah, no problem. Good job. Just one thing, make sure that didn't say 1.5, that just says half. I know there's a weird spacing when it wants to say 1.5. There's like this little lone one out there, so it gets confusing. But make sure that you're reading that visibility correctly. But yeah, METARs are tricky. They're not fun. But good job. You guys are doing really good. A lot better than I did. Let's see who else we got. John's mic is KIA. So we'll jump over him. Marisa. I'll give you this one. This is a fun airport. I'll never forget this airport.
I don't know where KKH is.
Paducah.
What?
Paducah.
Okay. On the 20th day at 23:53 Zulu, we're at 070 for wind direction and 4 knots with 10 statute miles of visibility. We're overcast 11 degrees Celsius, and then 83 for our dew point, our altimeters 3030, and then our remarks automated with precipitation. Sea level pressure.
Yep.
262, and then temperature. More accurate reading, and so we're at it's at 0.83 for the dew point, and is it 10.6 for the regular?
Yep. 10.6 and 8.3.
Okay. And then the next one is this is the temperature high over the last 6 hours. So it's at 11 degrees. And pressure is 0.89.
Nope. So this is the low over the last 6 hours.
And then the last one is pressure.
Yep. Temperature. I'm sorry. Pressure tendency. Good job. All right,
Jared,
Matt.
can you hear me? This is John.
Yes. Holy smokes. He's alive.
I was able to call in. Yeah, right?
All right. Okay. Here we go. I'm going to give you Cape Girardeau. I don't know how to say the name. Cape Girardeau? Something.
Okay, we'll give this a try. So on the 22nd at 23:53 Zulu, what looks like automated. Is that what that
Yeah.
means?
Perfect. Good job.
Winds at 320 degrees, 10 miles visibility. Overcast is 700. Temperature is 9 degrees. Dew point is 7 degrees Celsius. Altimeter is 30.31. And remarks automated. The sea level pressure 26. How do you say that? 26.2 or 26.6?
It's in millibars, so I think so.
Just
26.6, 266. I don't know. I'll be honest with you. I'm not 100% sure. Adam might know.
And then the accurate temperature is 8.9 degrees, and dew point is 6.7 degrees. The high is 9.4. Oh, sorry, that's the low. The low is 9.4. The high is. Is that a high?
Uh-huh.
Okay. The high is 9.4. The low is 6.7. I guess that makes sense, just looking at them.
Yep.
And the last is I'm blanking on that one.
Yeah, the last 24-hour pressure tendency. So it looks like there's been zero change over the last 24 hours. That's how I would read it.
Okay.
But yeah, great job. So what's the difference? Who can tell me what the difference between auto here and automated there is?
I believe the auto that's spelled out is it means automated weather observation. It's like a computer telling you the temperature, correct?
Yeah, so it's the METAR was generated automatically by a station. No weather observer intervention kind of thing. Okay, what is this one?
That's the type of station that, like, if it says automated 01 or automated 02, one is just more upgraded than the other. Like, I think with AO2, it provides precipitation.
Yeah, so AO2 is precipitation discriminator. So it's an automated weather station with a precipitation discriminator. AO1 is an automated weather station, and yeah, that's it. Automated weather station. It can't tell
kind of
us,
like,
it can't discriminate the type of precipitation that's falling. It just goes, it's wet outside.
So kind of like if you're tuning in on your ASOS, you would have a automated weather observation. That's where you would see that auto come in.
So the ASOS, yeah. So the ASOS is just one of these stations. So an ASOS is either going to be classified as an AO2 or an AO1. Just depends. So good job. Matt, did you do one or?
No, not yet.
Okay. There you go, Matt. Oh, crap.
Chicago.
I broke it. There we go.
This is a special or specie, so it's something's changed quite a bit. So it's a specie report at Chicago O'Hare, the 23rd day at 0004 Zulu. Winds are 60 degrees at 9 knots. 10 statute miles of visibility, overcast at 2,400 feet. Temperature is 3 degrees Celsius and minus 2 degrees Celsius on the dew point. Our altimeter setting is 30.41. Remarks, automated station with precipitation intensity.
Discriminator.
Sorry.
There you go.
Discriminator. Yeah.
Good.
And the more accurate reading for the temperatures is 3.3 degrees Celsius and negative 2.2 degrees Celsius.
Beautiful. All right. We're done with METARs. Love you, METARs, but I don't love you. Okay. Good job, guys.
I was trying to.
Yeah. They get a little easier as time goes on. Okay. Now, yesterday we talked about legal to go, and we also talked about alternate. Do we need an alternate? So, for each one of these, this is the one we're going to do as a class, right? So, legal and alternate. Okay, so here we have an ETA. Yesterday, I just gave you a TAF and I said, out of all of these lines, are there any where we would question whether or not it's legal to go? And the answer for this TAF would be what?
Yes.
Okay, which lines would I go, I better check the chart on?
The second and third.
Yeah. So those two lines, I'd be checking my charts just to make sure that I have an approach into Oklahoma City that would basically make me legal to go, right? Now for alternate, so legal, we'd question mark both of those and go, those two, I'm going to have to look at a chart. Now, with that knowledge, are there any lines in this TAF? Oh my gosh, stinking computer. Are there any lines in this TAF that require an alternate?
Just about all of them except the 7,000 and the 3,000.
Okay, does everybody see that? Those are the only two time slots that don't require an alternate.
Okay, I see where this where it was going. Okay.
Okay, so we looked at Oklahoma City. We, in fact, still have the chart up. So let's knock out whether or not this is legal to go. Okay, I see that I have 4 usable ILS approaches. Okay, we're not going to look at Cat 2 or Cat 3 or whatever. We're just going to look at our ILS approaches. So, do I have, or what are my landing minimums for this approach? Hold on, it's thinking. What are my
Okay,
landing
I was just
minimums?
200 and a quarter.
Okay, 200. Nope, not a quarter.
Sorry, 200 and a half.
Okay, 200 and a half. Yay! So what are our landing minimums? 200 and a half. We answered that question. Oh my good gravy. Okay, we answered that question. Our minimums are 200 and a half. Is there anything below a half-mile visibility on this TAF?
No.
Okay, so we don't even have to look at our ETA at this point, right? We know that this entire TAF is legal to dispatch. Does everybody see that? Here, I'm going to actually add a little section right
if there's parts of it, if there's parts of it that aren't legal and parts of it that are legal, then what would you write down for the legal part?
We'd have to look at our ETA. Okay, that's when we would apply our ETA and go, at my ETA, does my ETA fall in that time where it's not legal to dispatch? So let's just say, okay, everybody close your eyes. Just teasing. I'll just shut it down here for a second. Okay, I'm going to take this off. We're going to go like this. And we're going to go like this. Okay. All right, open your eyes. Here we go. Boom. Okay. Now, are there any lines that are below? We've got our landing minimums here, right? We know that our landing minimums are 200 feet and a half mile. When we're looking at legal to go, what is the only thing that we are concerned with?
I'm not quite sure what you're...
Visibility.
Well, yeah, I don't know what you're asking, but it's you've got a quarter mile in the time range of 1800 Zulu.
So what I'm asking is landing minimums. When we're looking at legal to go, the only thing that we are concerned about is the visibility. We don't even take the ceiling into consideration. Okay.
Right. So the 1600 inside, which would be the 18 Zulu, has a quarter mile, so it's not legal to go.
Okay, slow down. Okay, so we look at this half-mile visibility, and we go, is there anything in this TAF that is below a half-mile visibility? Yes.
C.
This line right here. Oh boy, I'm too zoomed in. Okay, this line is below a half-mile visibility. Now we're going to go, okay, what is our ETA? 1800 Z. Where does our ETA fall in this TAF?
Highlighted.
In that highlighted line. So at 1800 Zulu, are we legal to dispatch this flight?
No.
No. So do we even care if it needs an alternate or not?
No. Now we can go to Black Panther.
There
I'm
we
just kidding.
Okay.
So while you were going through that part, talking, my head jumped ahead and looked at, okay, so I'm looking at this like a couple of hours before the flight. I have a legal no-go, but I know that it would, if I had legal, it would be needing an alternate. And then, I don't want to dismiss it because inside of an hour I might be legal to go. Is that where you're going with that, or you just say no go?
No, I just, right now, for the sake of our brains and whether or not we fry them like an egg, we're just going to just think only about, is it legal at my ETA to dispatch? We're not going to think about how to fix the problem or nothing right now. We're just going to go, nope, we're not legal at 1800Z. That's it. Does that answer that question?
Well, I guess I'm just curious. You're the dispatcher sitting there, and you get that. Then what's the next step? I guess. But
I would call my
Send them to the
supervisor.
alternate.
I'd call up my supervisor and I'd say, hey, I've got an ETA of 1800Z going into Oklahoma City, and my TAF is not legal at 18Z. He's going to look at it and he's going to tell me, okay, we're going to delay for 2 hours or 3 hours or 4 hours, whatever it takes to get us into a legal TAF, the next line basically, and then we're going to send the flight at that time. We'll just delay it. Okay? But I don't want you guys to worry about that right now. What I want you guys to worry about is solely, are we legal to dispatch at 1800Z? Nope. Does that make sense?
Yes, sir.
Does that answer your
We're
question?
technically the ones. So we're the ones that are delaying the flights whenever we need to. Like when you're sitting at the airport and they're like, your flight's going to be delayed for 2 hours. Like, that's us. We're that guy.
Yeah, so going back to our FARs, what are the responsibilities of the pilot and dispatcher? I'm going to answer your question by asking a question.
Pre-flight planning, PP, delay.
I remember now that you phrased it like that.
Yep. So we're gonna go like that's. We're gonna make sense of everything that we've learned so far, and that's why I'm gonna answer your questions with a question, is because we need to be able to see where that FAR applies or where these different principles apply.
Right. Well, and as soon as you said that, like, it clicked. Like, the second that you phrased it the way that you did, like, I remembered it immediately. Yeah.
Yep. So yes, as a dispatcher, our job with the pilot in command is the pre-flight planning, dispatch release, and delay of the flight. Right? Now, solely as a dispatcher, our job is to monitor the progress of each flight, issue any information pertaining to the safety of the flight, and then cancel or redispatch the flight. Okay? The pilot doesn't cancel the flight. It is solely the dispatcher's job to cancel the flight. So, in answering your question, yes, we are the one, between us and the pilot in command, we make the decision to delay the flight. Boom shakalaka. You know what? My brain's fried, so I guarantee your brains are fried. Let's take a break. Do you guys want dinner break? Okay.
See.
How long do you guys need?
30 minutes.
30 minutes. Okay. We will see you guys back on at 7:20.
Perfect.
All right. I'll reprogram my brain with some pizza.
There you go. All right. Is everybody back?
Is there?
You guys ready for fun?
fine.
Yes.
Okay. Yeah.
All right. So we already decided that this one, with my changes, is not legal. Okay. So I'm going to leave these on the Google Drive, so you guys can go back and look at them and figure out, how we did all this. So this will be for your guys' review as well. Okay. First thing we need to ask ourselves is, I want to hear everybody say it.
Are we legal?
Is it legal?
Yeah. Okay. Is there anything that's of concern as far as legality goes in this TAF?
Yes.
Where?
The second line down.
Yay, our tempo. Okay. So our tempo, we take a quick look at, and we go, oh, let's look at our chart. We're going to XNA. Northwest Arkansas. Oops. Okay. What instrument approach procedure has the lowest minimums that we can use? ILS. Here we go. ILS runway 16. What are our landing minimums for runway 16 ILS? Can you guys see it?
200 and a half?
Yep.
Your screen is very small.
200 and a half.
Okay.
Wonderful. Okay, let's go back to our document. Okay, so now that we've looked up our landing minimums, we don't ever have to look at them while we figure this out again. Okay, so is this above our legal minimums?
What's above our legal minimums?
Yes.
Okay, how did you figure that out?
Well, you have a 1 mile, you need a half, but up there, and you're also good on your half. So.
All right. So we are only concerned about the visibility when we're determining our legal to go. So if there is anything less than a half, we would have to look at our ETA and see if our ETA falls in that line. Since there is nothing that is 1/2 or below 1/2, we know that every single line in this TAF is now legal to go. Okay, let's look at our alternate. What line does our ETA fall in?
21:15 Zulu.
Okay, that's our ETA, but what line does it fall into?
Oh, okay. It falls into the last line.
Beautiful. Does everybody see that?
Yes.
Okay. Can you refresh me on how it became legal from the point to when it first wasn't legal on the tempo?
It never was illegal. Never ever was it illegal. What we are doing is we're looking, if we see anything at 2 miles or less, that is telling us we need to go to our charts and make sure we have an approach. We need to look and find our landing minimums, basically. So
And the
anytime,
landing minimums were 200.5.
yeah, anytime I see this 2 miles or below, I immediately go, let me check my charts really quick. Okay. So I go into my charts, I pull up the airport, I find my ILS because the ILS drives the lowest minimums. I look, I've got an ILS approach with 200.5. My landing minimums are 201.5. Now we use this visibility to determine, are we legal to go? Is there anything less than 1/2 mile visibility in our entire TAF? No. So we know this entire TAF, regardless, is legal to go.
Oh, okay. Okay, I get it. So even though that says 1 statute mile, the landing minimum said 200.5, and since everything is above a half visibility, you are legal to go.
Yes.
Okay.
Okay. Now we're going to pause there. Does it matter if I had 1/4 up here? Does it matter whether or not I have 1/4 in my TAF? Does that change that we are legal to go on the 23rd at 21:15 Zulu?
No. I was just gonna say I think it would change because isn't 1/4 lower than 1/2?
It is lower than 1/2, but what is our ETA?
21:15. So it would be legal because we're falling underneath the last line.
Right. So we are only carrying, all we're doing, the only reason why we're trying to deductively and intuitively eliminate everything down to, is this legal? Okay. We're going to go step by step and is this legal? Okay. So the first thing, we look for our visibility, anything below 2, we check our charts. We see that our charts give us our landing minimums of 200.5. We go, is there anything in here that is below a 1/2 mile visibility? There is. Okay, now let's look at our ETA. My ETA falls in this line. So do I care that I have a 1/4 mile up there? No, I am legal to dispatch because my forecast says 3 miles of visibility. Okay? It doesn't matter if it's in the TAF. What matters is when our ETA falls in that line. Okay. Now that we know what line our ETA falls in and we know that we're legal, do we require an alternate looking at this line?
Yes.
Yes.
Okay. We do. Why do we?
700 our ceiling is only
Okay.
Yeah, the overcast is only at 700.
Okay, so we apply the 1, 2, 3 rule. What is our ETA window?
So it would be so 23. So it would be 1900 to 2100.
Nope.
2015 and 2215. 1 hour before and 1 hour after.
There we go.
Oh, sorry, I'm looking in the wrong spot. Well,
okay.
What I was looking at was the 23-2000.
You're looking at the valid time of that forecast. ETA window is our ETA, like the hour before and hour after our ETA. Okay, so 2015 is an hour before, 2215 is an hour after. That means that our 2-hour window is from 2015 to 2215 Zulu. Do both of those times fall in that single line?
Yes.
Yes. Okay. Good. So, yes, we require an alternate because we have overcast 700. Okay. Here we go again. All right. Okay. Looking at this, hold on. I'm going to adjust this just a little bit. And just hurry and knock this out. Oh, man. Okay. That's as far as I'm going to go right now. Okay. Okay, looking at this. Is there anything that is of concern in this entire TAF that would make it like would we ever even have to check our charts with this TAF?
No.
Why?
Because every line has. Go ahead.
Oh, I was just to say everything's like super good to go. There's nothing below 5 on the visibility, and there's nothing below.
That's all we're worried about is our visibility. So there's nothing below 5.
Yep.
Are we legal to dispatch?
Nope.
Yes.
Totally.
Okay.
You.
Yes. Okay. Now, do we require an alternate anywhere inside this TAF?
No.
Nope.
Why?
Everything is above
everything's
2,000.
above 2,000.
All of our ceilings are above 2,000 feet. So do we require an alternate? No. Did we have to look at our ETA closely? Did we have to look at our landing minimums? Did we have to figure out our ETA window?
Nope.
No to all of those. Pretty easy TAF, right? That just made our lives a lot easier. Okay. Good job, guys. Okay, someone that hasn't answered yet? Is there anything of concern in this TAF as far as legal to go? Bueller?
You just gotta call on someone.
Greg?
Sorry. No, we're all 6+, so.
Okay, we're 6+.
So we're legal.
So we are legal in every line. Don't even have to worry about this, right? Alternate. Do we require an alternate at all?
No.
Why?
We have a minimum of 5,000 feet on all of them.
On all of our ceilings that we're reporting, this doesn't constitute a ceiling. This doesn't constitute a ceiling. This is a ceiling. This is a ceiling, but both of them are over 2,000 feet, so we do not require an alternate. Did we have to look at landing minimums, ETA window, or even consider our ETA?
No.
No. Boom. See how quick they can be? Oh my gosh. So much fun. Okay. Here we go. Marisa, is there anything of concern as far as visibility goes in this TAF for legal to go?
Yes, for the first line, I have 2 statute miles.
Okay, so what are we going to do?
Parts, see what our minimums are.
We're going to figure out our landing minimums. Okay, so we're looking at banana. Holy cow, look at all those approaches. Okay, what approaches are we going to look at? ILS. Okay. What are our minimums?
200 and a half miles.
So when we look down in this corner here, we can see 201.5 mile visibility. Good, good, good. Okay, so we come back here. We hurry and write down 200.5 for our viz. Okay. All right, now let's look at our ETA. Oh, wait. Okay. Nope, sorry. Back up. Okay. Is there anything in this TAF below a half mile of visibility? No. So are we legal to dispatch this flight? Okay. We are legal to dispatch this flight. Do we require an alternate?
Yes.
What lines?
The fourth line, the first line and the fourth line are under the 2000.
And this line?
Yes.
Okay. Good. Anything else?
No, the other ones look good.
Okay. All right. That being said, where does our ETA fall?
Our ETA falls on this between the second or the third and the fourth line.
So
That one.
falls in there, right? Okay. What is our ETA window?
An hour before, so 6:30 and 8:30.
So from 0630Z to 0830Z. Okay. Now that being considered, does either of those times fall into any other line on this chart? So our ETA, we know our ETA falls right there, right? But our oh, sorry, go.
And the one right below it, the second and the third line.
Right.
0 below it.
Right. So our ETA window falls between these two lines. Okay. Our 0830 dips into this line. Our 0630 is in this line. Okay. So looking at those two lines, do we require an alternate?
Yes.
Why?
Because the second line with the overcast clouds of 1,500 feet are below the 2,000 foot minimum.
Okay. So do we require an alternate? Yes. Beautiful. Very good job. Is this making sense to everybody?
Yes, sir.
Do you guys think
Yes.
you could do it by yourselves?
Whoa.
Yes.
Maybe.
Okay. We're going to do a couple more. Not all of them, okay? But we will do this one. Okay. So anybody know where that's at? I bet Adam does. Evansville. Who knows where Evansville is? Nobody knows where Evansville is because nobody really cares about Evansville. Oh, hey.
I've never even heard of Evansville.
Yeah. Okay.
I've heard of Adamsville, Kentucky. It's been on a couple movies, so yeah.
So, okay. Let's see. Who else wants to take a stab at this? Corey, do you want to take a try? If you got a mic. Greg, did you get one?
I did, but I'll do it again.
All right.
So the only one I'd be concerned on is that 2 statute mile tempo.
Okay. So what are we going to do?
Go look at our plate.
Okay. So we'll come up here. We'll search Evansville. Oops, hold on. All right, what approach are we going to look at?
So that first ILS.
Okay, take a look at this ILS. What's our minimums off of this?
So I have 203/4.
Okay, 203/4. That's pretty good, huh? What was the lowest visibility on that, Taff?
That was 2.
Yep. Okay, so do we care to look at any others?
No, we're golden.
Okay, we know that we're good to go. So.
Is that Indiana?
Let's see.
Sorry, what?
Yeah, Indiana. Evansville, Indiana.
That is Kentucky.
Yep. So, let's see. Oh, there is one that's 200.5, so I just looked up for kicks and giggles. Okay. So we do have one that's 200 feet and 1/2 on the Viz. Okay. All right. So looking at that and considering our visibility, are we legal to dispatch this flight regardless of where the ETA falls?
Yes.
Do we require an alternate for any of these lines?
Yes.
Which lines?
All of them, looks like.
Okay. Why?
They're all less than 2,000.
Yep. Perfect. Every single line is considered or requires an alternate. Okay. We could go through and we could mark every one of these. Overcast. Broken. Overcast. Broken. Ooh, what's that CB?
That's cumulonimbus in the area, so, and you have light, you have all kinds of crazy light, thunderstorms and rain and cumulonimbus.
Yep. What about this too? Does that require an alternate?
No.
Yep.
With, well, yeah, it does because you've got broken, but.
The visibility doesn't require one?
Sorry, what do you mean?
So the visibility wouldn't require an alternate? If it, say this was broken 10,000, would the visibility require an alternate?
I'm not sure what you're driving at. We're legal to go.
Okay. Let me change this really quick. Okay. Now is that line require an alternate?
No.
Why?
because you've already got a legal to go, but you have broken at 100 or 10,000.
Okay. What's the 1, 2, 3 rule?
So you need hour before, hour after, and then you need 2,000.
Okay. And what's
and 3 miles.
3 miles?
So I guess you would, yeah.
Yep. So it does fall under that requirement, requiring an alternate. Cool. So yeah, this one was it. Like, oh wait, no, at like that. So both of those factors require an alternate. But like I had it before, if it was even broken 10,000, even though our visibility, or even though we have a high ceiling, our visibility would require an alternate. Does that make sense?
Yeah, before it was failing one of the 3, now it's failing 2 of the 3.
Yep. And either way, it's failing one of the 3, so it requires an alternate.
Yep, got it.
Okay, good. Okay, so we don't even have to look at our ETA. We don't even have to look at our ETA window. We don't care. Every single line requires an alternate. Okay. Is this a lot easier than me just saying, okay, are we legal to dispatch this flight? Consider the ETA.
Yes.
Good. Because I was like trying to figure out a way to make sense of all this garbage. Okay, Matt, are we legal, or do we have to take any of these lines in this TAF into consideration for legal to land?
Let's see. Legal to land.
Legal to go.
Oh, sorry. Second one.
Yep.
The second line.
So what do we do when we see that?
You would go to our ILS approach chart.
Okay. So we're going to look at, oops, forgot the airport already. St. Louis. Okay. And if we have an ILS, we're going to go to our ILS, right? Because that drives our lowest minimums. Okay. Right off the bat, we see an ILS approach 200.5, right?
200.5.
Okay.
So next we would look to see if anything is less than a half mile visibility. And there, it looks like there isn't. So
are we legal to dispatch?
Yes.
Okay. Do any of these lines require an alternate?
Four lines do. The first and second line, and the last two. Oh, sorry, and the third line and the fifth line.
Okay. Does this line require an alternate?
No.
Okay. Good job. Why?
Because you're right at 2,000 feet.
Yep. So it's below 2,000 feet. Ceilings are less than 2,000 feet. So at 2,000 feet, we're good. Okay. So this line doesn't require an alternate. Looking at our ETA, what is our ETA window?
So it would be 1930 to 2130.
Okay. Taking our ETA window into consideration, do we require an alternate?
Hold on, I'm trying to find it. So that ETA would fall under the second line.
This one?
So I'm looking at. So it says 23rd day at 20 Zulu. The third line.
So the third line has part of our ETA window in it. And what other line?
And the fourth line.
Right. So our ETA window, even though our ETA is 2030, our ETA window puts us into that third line, right?
Mm-hmm.
And keeps us in the fourth line as well. So we consider both of these lines for our do we require an alternate? So do we require an alternate?
Yes.
Why?
Overcast at 800 feet.
Okay. Wonderful. Is this making sense, everybody?
Yeah.
Yes. It sure did take a minute, but it is now.
Okay. CJ, you're up. Okay, looking at Fort Wayne, Indiana.
Fort Wayne, Indiana. All right. So we have. So legal to go, we'll have to check out the 2 statute miles of visibility on the third line down.
Okay, so we'll check out this one, right? Where are we going to check that out?
On the ILS approach plate.
Okay, so we'll look at our approach plate for an ILS.
And
Oh, come on. Dang it. It probably, yeah, it pulled it up, but OCD kicked in. Okay, ILS. Okay, our first one, what's our minimums there?
half mile.
And
200 feet.
Yep, so 200 and a half. You always want to make sure that you state both of those, even though we're only going to apply the visibility.
So nothing's below a half mile, so we're legal to go. And then as for an alternate, it looks like we're going to need one for all of them.
Okay, every single line's going to require an alternate in this one.
Yep.
Why?
Everything's below 2,000 feet.
So all of our ceilings are below 2,000 feet. Is there anything else that would require an alternate? That would mean that we require an alternate?
If the if it was, let's see, are you thinking the like 1 hour before and 1 hour after?
Yeah, so what's
our
the full
time of arrival?
Yeah, what's the full 1, 2, 3 rule?
So we would need 1 hour visibility before 2:30 Zulu, which would be from 1:30 Zulu to 3:30 Zulu. And then we need to be above 2,000 feet, and we would need 3 statute miles of visibility, except that for this one, we only need a half.
Nope. Don't mix up legal. Don't mix up legal to land versus alternate. Okay.
Oh, okay. Yeah. So our window, yeah, from the 1:30 to 3:30.
Yeah. So what I'm getting at here is the last thing you said was 3 miles of visibility. So even if we had ceilings that were higher than 2,000 feet, this is another factor that we'd have to look at that requires an alternate because it is below 3 miles of visibility. So we can't get too focused on just looking at our ceilings for alternate requirements, okay?
So anything 2 and below, we would have to check it for regardless.
Yep. So
okay.
So regardless of what this says, regardless of anything after this mist here, we have 2 miles visibility. That requires an alternate. Looking at our sky conditions, we've got an overcast 300.
Oh.
That also requires an alternate. So there's 2 things on that line that require an alternate.
Because it's in our window of time, we still have 2 statute miles of visibility, which also makes it require an alternate, regardless of what the landing minimums are.
Yeah, so, yep.
Okay.
And so we don't even have to take in consideration the ETA. We just have to look at all of these lines require an alternate, and this is why. Overcast, 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 all below 2,000 feet, and we've got a line that also says 2 statute miles of visibility. So every line every line in this TAF says we need an alternate. Okay. Let me see what time it is. All right. Here's your homework. All of these that are left. Okay. I want you to go through and do the same exact thing. Okay. I'll put man, I'm trying to figure out how you guys can pull up landing minimums. I'm just going to tell you that your landing minimums are going to be 200
Garrett,
and a half.
just use airports. Garrett, just use airports that are in the JEP charts that they already have.
Okay. All right. Okay, so I'll just format this document here.
Yeah, just change. All you got to really do is just change the name of the airport. You can keep the weather.
Oh, okay. Mm-hmm.
Pretty much anything Denver and west.
So all of our hubs, huh?
Major airports, that is. Yeah.
Okay. Everybody knows where to find the JEP charts that we've given you, right?
Let me go look 1 second.
I believe they're in our Google Drive.
Yep. Do we have Phoenix? Should I do a SAT
Are they
4?
in the? Are they in like the advisory circulars? Where am I looking?
So they're going to be.
You're looking in flight planning.
Yeah. So if you go
under flight planning.
Yep.
Right.
So if we go into the flight planning, so go into our Aircraft Dispatch Academy January 2018, go into flight planning and JEP charts right here, that top folder. That has all of them.
Oh, found them. All right.
Okay, let me finish editing these. Okay, we'll change this to costs. PSP. I think there's an ORD one too, isn't there? Nope. Ontario.
Not Chicago, no. Give them a Palm Springs. That'll really throw their landing minimums for a loop.
Oh, I'm going to give them
Don't
the
you
Palm
dare.
Springs on a good one too. I'm not going to let you guys cheat though. Okay, that's your homework. You guys have all of this here, okay, to fall back on. Okay. So if you get confused, just go up above and look to see how we figured out on the ones above. And if you need, Adam and I are always here, right? At least we try to be.
On these approach plates, we're always going to be looking at the straight in landing runway.
Straight in
Box.
landing ILS, full ILS.
Okay. I just picked like a random one. I'm looking at, let's see, just Grand Junction, and I was just making sure I was looking at the right box because there's one of them, yeah, that says with altimeter settings, and then the one above it says just straight in landing runway, and that's the one that we need, right?
Yep.
Okay, yeah. And then, yeah, ILS. Grand Junction is 200 feet and a half mile.
Yep.
If anybody was wondering.
Okay. There you go. That's all ready for you guys after we get done with class, because I need you guys for the rest of the stuff we're going to cover today. Okay. Once again, we're baby stepping into our is it legal to dispatch and does it require an alternate? Okay, there's more to it, and we're just going to keep adding to it, but we want to make sure that you get the basics down before we start throwing curveballs at you, okay? Okay. Now we're going to talk about other charts. We've kind of showed you guys these charts at various times in this class already, but now we're going to talk about them and kind of dissect them a little bit. Okay. Once again, just the same as everything else that we've talked about, and I know I'm beating a dead horse here. It's up to you guys to really continue studying these. We're providing the material that you guys can fall back onto and read, but one day of going over these in class and even when we're flight planning isn't sufficient to completely get you guys comfortable looking at these charts. You guys will need to look at them yourselves at some point in time and look at, you know, the reading or the PowerPoints, whatever it is, to help you understand these charts. Even rewatch this video, this section of the video, because this is something that it's important. It's extremely important, because the first thing you do as a dispatcher when you get in the morning is you do a weather brief, and you just kind of look at the weather overall across the United States to get an idea of where are my problems going to be, and how can I, you know, just kind of set your mind right as to what you need to be watching for when you're dispatching. So, all right. This first chart that we're going to look at, this is called an AirMet chart. Okay. What this chart does is this is going to give us a whole bunch of colorful, beautiful lines. But more than that, it's going to give us, as we break it into little sections here, this is going to give us our icing across the country, the areas that they're predicting icing is a possibility, the areas of turbulence, and the areas of low visibility. Okay. So when we look at this chart as an overall chunk here, it's really confusing. Lucky for us, we can break it down and take a look. So over on the side here, we can see these boxes, right? There's an arrow here, and it goes to text on the perimeter of the states here. So we can read this, right?
I got one question.
Uh-huh.
So these charts are areas of icing, area of visibility, and areas of what else?
Turbulence.
Okay, got it. Thanks.
Yep. So looking at this, we have an air met over this section of the United States. When we look at it, this text is pretty intuitive. We can understand what this text is trying to tell us, right? It's saying in this area, there's a probability that there's going to be moderate icing. The freezing level is 17,000 feet and then continues beyond, or what is this? Oh boy.
Contingent?
Contingency or it can't be continued because there's a G in there. So
No, hold on.
Contingent. I'm gonna say
Don't
contingency.
confusing. Don't add confusion. Here we go. Continuing beyond 3 Zulu through 9 Zulu. Okay. So it's giving us our time. Okay. We can see that all over the chart here. It's going to give us a flight level that they're forecasting the icing to be, and then it's going to give us a time that they're predicting that to be possible in that area. Does everybody understand that? Okay. Notice all of them are moderate ice. Okay. Then as we go throughout the day, we can see on this chart, we can see it change. Oops, hold on. Oh boy. Let's slow it down. You can see it change throughout the day. So we have different, if we look up here, you can see the times, okay? As it goes through the times, we can see it change throughout the US. Okay, now let's look at our turbulence. Our turbulence, the good thing about these charts is almost every single one of them has a key, okay? The yellow boxes are surface-based turbulence, and the green boxes are aloft turbulence, okay? The white boxes are surface winds greater than 30 knots, right? So let's pause it. So the green box here says that there's moderate turbulence from 18,000 feet to 39,000 feet, continuing beyond 3 Zulu through 9 Zulu. Moderate blowing? Yeah. 15,000 feet, continuing beyond.
Below.
Oh, below. Moderate below 15,000 feet. Thank you.
what's really helpful is the fact that these are pointing to the locations.
Right. So we can see that there's two boxes overlapping each other here, right? And we can just read through each one of these. Okay. This one is a sustained surface winds greater than 30 knots. Expect developing from 21 to 00 Zulu. Continuing beyond 3 Zulu, ending beyond. So basically from 3 to 6 Zulu.
Garrett, so on that, those overlaps, they're overlapping because of that altitude, right? So they're layered, basically.
Layered turbulence. So yeah, so kind of what you look at is you go, look, we've got surface turbulence that's going to be, lower level turbulence that's going to be basically throughout the southwest of the United States, spreading over almost the entire central United States and going up into the northeast corner of the United States. You just kind of make a mental note, these areas of turbulence. We can see this high level turbulence or aloft turbulence kind of follows the same pattern. So as a dispatcher, that's what I'm using this chart for, is I'm just going to kind of take it in that there's a good possibility that turbulence is going to occur in these areas, whether they're at the surface or aloft. Okay. These little stars here on the map, they indicate low-level wind shear. Okay, low-level wind shear over the coastal waters near Dallas-Fort Worth. Low-level wind shears near Dallas-Fort Worth. So yeah, these are just indicating low-level wind shear over CHI. So yeah.
So when it says moderate below 7,000.
Oh, sorry.
Sorry, I just had a quick question. So like when it says moderate below 7,000 feet continuing beyond, when it says 03 Zulu, is that basically saying 300 Zulu and
yeah, 0300 Zulu. Yep. So that's just giving us a timestamp of when they're expecting that to be an area of turbulence. Okay. And it's the same with all three of these charts. It's just we're talking about IFR or VFR on this visibility chart. So the red areas are areas of IFR at the surface. Okay. And the pink areas are where there's mountain obscuration. Okay. You don't need to take too many notes on these, just general notes. But yeah, so looking at this chart, we get an idea of where we may be encountering some low visibility across the country.
And the red is IFR, pink is IFR.
Yep, that's the beauty of the keys up here in this corner. You don't have to remember what they are, what the colors mean. They'll tell you on every single one of the charts.
Oh, that's nice.
Okay. Sigmets. So a sigmet, does anybody remember what a sigmet is? Have we talked about sigmets? I'm pretty sure we have. Okay.
Sigmet are, I have it written down here.
I don't see it written down in my notes.
Sigmets are pressure, right? Pressure and winds.
Nope. So it's significant hazardous weather, such as like when we talk about significant hazardous weather, we're talking about areas of like icing, poor visibility, turbulence.
So that's what signet is.
So yeah, so that's what, when we talk about sigmets, that's what we're talking about. So any of these areas that have that severe or significant hazardous weather is going to be outlined. If it's icing, it's going to be in a blue box.
I could have read the legend there.
Yeah. So icing is going to be in a blue box. Surface base is going to be in a yellow box, and then aloft is green box. So if it's turbulence, it's going to be in a yellow or green, blue for icing. And these are areas of significant. So that air met is not necessarily significant. That air met's just saying, hey, might have some. It's not, we're not really sure if these, it's super general. When we get a sigmet, it's going to be a lot more precise. We're going to get an area that's like, it's going to be a box that's like this corner of the state. Okay. It's going to be narrowed down. This is probably where it's going to be. Okay. Now, when we talk about convective sigmets, what does convective mean?
Means storms.
Yeah, so convective is lifting or rising action, right? when we think about convective cloud, we're thinking about cumulonimbus, we're thinking about thunderstorms, we're thinking about, severe thunderstorms. So that's what this chart's going to point out, is those severe thunderstorms, or severe storm weather. Okay. As you can see, these boxes are a lot more small and are basically narrowed down to show these areas of severe weather occurring, severe convective activity. Convective activity is super dangerous for airplanes because it's a rising action and a falling action. Basically, it's extremely turbulent, right? So we can, in these convective SIGMET boxes, some of these clouds, if we looked at the tops, some of these clouds could be, 60,000 feet tall. And so that's why when we look at convective SIGMETs, we've really got to be careful flying too close to any severe weather happening in this box. Okay, it doesn't mean that we can't fly through the box. It just means that we've got to, use extreme caution and be extremely careful. Watch our aircraft go through them and make sure that they're not getting eaten up by a thunderstorm, right? Okay, so that's convective SIGMETs. Each convective SIGMET is also going to be identified with a numerical and a you know what I'm saying, a letter value. We can use that identifier to look up the text for that convective SIGMET, and basically what we're going to get when we get the text is it's going to show you, or it's going to give you a textual description of where the convective SIGMET is, basically this box, right? And then it's going to tell you what kind of weather they're expecting in that box. It also will tell you the valid time for that. So convective SIGMETs are good for 4 hours, right? No. Oh, Lord. Let me think. Convective SIGMETs are valid for 2 hours unless it's a hurricane, then it's good for 4 hours. That's where I'm getting the 4 hours. So, so convective SIGMETs, once a convective SIGMET has been issued, the valid time of that convective SIGMET is 2 hours. And so basically for the next 2 hours, we have to be super cautious in that area. Now they're going to update those convective SIGMETs hourly to help us track the storm, basically. Does that make sense? So yeah. I want you guys to write a note, write that down. A convective SIGMET is valid for 2 hours. Make sure you memorize that. That may come up at some point in time. Has everybody got it?
Yes, sir.
Okay. Surface analysis chart. Okay. This is talking about what's happening pressure-wise and frontal-wise over the surface, like on the surface. Okay. Okay, we can see here that it will identify clouds and precipitation. Okay. We can see here with this key, we can see the rain A light green is light rain, and a red is areas of heavy rain. So you can see some spots of pretty heavy rain right there. Snow is identified with blue. Blue's cold, right? Snow, precipitation. Pretty easy to identify. Okay, we see some fronts here. What is what would this front be?
That would be occluded. No, that would not be occluded.
Nope.
That'd be a stationary front.
There you go. Okay, what is this?
Cold front.
And this.
And a warm front.
Okay. Somebody else, what is this? Anyone?
It's a high front, and it's going it's going clockwise.
Okay. High is.
What are you pointing at? The H?
Yes.
Oh yeah, the high pressure.
Okay, high pressure, and you said it's clockwise and down, right? Is
Correct.
Is it colder or warmer air?
Cold.
Okay. And what is this?
Low pressure.
Okay, low pressure. What way does it rotate?
Low pressures spin. You just told me they go counterclockwise.
And
Up.
Yep.
And
Counterclockwise.
And they're unstable.
Yep. So counterclockwise and up, unstable, right? Warm air. Okay. Good. What are these light tan lines?
ISO something.
Isobars. Good job. Okay.
Isobars.
And what are these numbers, these light tan numbers associated with the isobars?
The hectopascals.
Yeah. Good job. Millibars or hectopascals?
Millibars. I was going to say millibars.
Okay. What is this?
It's a
trough, isn't it?
Yep, trough. Okay, so a trough is what?
Dark lines?
Yeah, these dashed dark lines.
Trough is low pressure, right?
Okay, it's low pressure, but what more importantly about low pressure?
It feeds something.
I heard it.
Elongated.
Feeds
Yes. Marisa.
Cold air?
No. Marisa said it's elongated low pressure. Areas of elongated low pressure. Okay. So basically it's a low pressure that's stretched out over a large area. Okay. Good.
The low pressure trough. That's what I was thinking feeds.
Yep. So it's a trough. Yep. So when we identify it, we call it a trough. And then if you're asked, what is a trough? It's an elongated area of low pressure.
Boy, those are tough to see on the map there.
Yeah, they kind of blend in, don't they? Okay. If this line were pink, what would it be? Or this line right here, if it were pink, what would it be? Or I guess like a purple.
Isn't that an
that's an
occluded
front.
Occluded front.
Occlusion?
Yeah, an occluded front.
Occluded.
Yep. Okay. And the other one, what's the other symbol we'd see on a map? So we've named all of them except for one.
Sorry, repeat that.
Okay, a dry line. Okay, let's see if this has the dry line on it. So when we see, let me zoom in on this.
The way you're pulling that up, isn't that the converging dew points or something like that?
So a dry line is where it goes from a moist to a dry line. So it's an area of moist air that meets with dry air. So it's like a definite line. You can go across a dry line and your body instantly gets chapped. It's hard to explain.
Do those happen more regionally, or can those happen like anywhere?
You see them in Texas a lot. Okay.
Oh, okay.
Okay. So this is what a dry line looks like. Everybody see that?
Yes.
Number 7. Dry line. This one is what? Occluded. This one's a trough. I think that's how you spell trough. Okay. This one's a stationary. These are the only ones that you have to know. This one's a warm. And this one is a cold. Okay. Dry line. Does everybody have that down? I want you guys to know those ones. Memorize them good.
Yeah, I wrote them down on the when you
Did you draw them?
Well, no. Well, yeah, I did. When we were reading those notes, it was already in the notes, I think, and so I just said, "Oh, I should write this down." So I got it from the notes.
Sweet.
I like that post-it note above your one you have opened.
Popular feature in Texas, Oklahoma, Kansas, and High Plains region. It's a boundary between moist, warm, tropical air and warm, dry air. A severe weather season feature. There you go.
Oh, severe weather season feature.
They make it a little more clear there, don't they?
Somebody did the homework for me.
Yeah, there you go.
Screenshot.
Everybody got it?
Yes, sir.
Yeah, a lot of people don't know in Texas that, you think of Houston and all the humidity, but Texas is so big it takes in all climates. But you get over in West Texas and yeah, exactly. You get out of the airplane and your skin shrivels up on the spot.
Yeah. Over in Amarillo. All right. Okay. There's your surface analysis chart. Okay, weather depiction chart. The only difference between this is giving us ceilings and precipitation type. Okay, I want you guys to know the different symbols for precipitation. Okay, okay, I'm going to post. Let me post something in the Google Drive really quick. Okay, you don't have to memorize all of them. But become familiar with them. Does that make sense?
So you want us to...
Hold on. Don't do anything. Hold on. Okay. I've just put it in the Google Drive. Okay. Here you go. This is what it's showing you. Okay. It's going to break down all of the symbols that you see, that you guys have seen, that you were just looking at on that chart. Okay. I mean, the ones that I really want you to know is like drizzle, thunderstorms, drizzle. You'll want to know fog. Let's see. Where's my rain? So here's our rain, our snow. I want you guys to just kind of like skim through this, but definitely pay attention to the common weather features that we see. Okay. This also will have your different front types. Oh, we forgot about the squall line. You guys need to know the squall line. Okay. I'm sorry. I thought I had them all. But this page that I just added to your guys' Google Drive, get familiar with it. Like I said, you don't have to memorize everything. Like, how often do you think we're going to see fog depositing rime, sky discernible? Probably very rarely. But how many times do you think we're going to see rain on these charts? Pretty much every single day. In the winter, we're going to see snow almost every single day. In the summer, we're going to see thunderstorms. Okay, thunderstorms. Almost every day. Okay, so just kind of memorize the ones that are common weather: rain, snow, drizzle, thunderstorms. Memorize those ones. The easy thing about it is once you get the basic ones down, like drizzle, rain, thunderstorms, then they just add them on top of here. You know, like each one of the symbols become very intuitive. The more dots you see, the heavier the rain. The more snowflakes you see, the heavier the snow. So just get familiar with them. This also shows you your weather chart symbols. Okay. Again, looking at this, the ones that I want you to have memorized are this one. Well, I guess those two that I just did. Occluded fronts. Okay. Let me make it a little bit easier to read so that when you guys come back and watch this, you know.
I was wondering if you could zoom in a tiny bit.
Hold on. Oh my gosh.
If you can't, that's fine.
No, it's the computer was just being dumb. Okay.
So what are these called again?
Okay. What do you mean? What are these called again? It says
So you said memorize like thunderstorm, drizzle, fog, rain, and then you said and you also want us to memorize these
these
and
fronts.
fronts. So also front symbols.
Yeah, so this has our fronts, okay? These are the ones I want you to memorize as far as the fronts go. Okay, screenshot those ones. I got to go down.
Wait, hold on, let me screenshot it right now. How do I screenshot it? How do I screenshot it?
You did it?
No, how do I screenshot it?
Control print screen. I don't know. I don't know how to do it on a PC.
Let me just take a picture of it on my phone and then
There you
do it
go.
all real quick. You're good.
All right. Okay. And the other ones, squall line, trough, ridge, and then the dry line. Pretty good dry line, I must say so myself. Okay, screenshot those. Everybody got them?
Mm-hmm.
Okay. So I want you to memorize those ones for sure. You definitely need to know those. You also need to know a high and a low pressure and what way they rotate. Okay? Like I said before, just memorize like the basics of this chart. Rain, snow, thunderstorms, drizzle, snow showers, rain showers. That's what you guys need to memorize on this chart. Other than that, that's pretty much it as far as these are concerned. But this is on your Google Drive. Study it, learn it, love it, understand it, and you'll be good. Okay? So looking at this, we can see that there's ceilings and we can see that there's snow. We also know, looking down here at the legend down in the corner, the blue areas are MVFR. So who remembers what MVFR means?
What, M or N VFR? Oh, M VFR.
Marginal VFR. So
marginal visual. Okay.
So marginal VFR, marginal visual flight rules. So when we talk about marginal visual flight rules, that usually means that the visibility is 3 miles or less, right? Isn't that marginal, Greg? You remember?
Say it again, sorry.
Marginal VFR is when we have visibility 3 miles or less.
That's correct. And so I'll just point out that all of this stuff we've been learning is new territory. VFR is incredibly simple.
Yep.
Means you don't fly most of the time, in other words.
Right. So IFR is instrument flight rules. IFR means that you can't see what's going on outside the cockpit or down on the ground below. Okay. IFR weather is basically we don't even look outside the cockpit to know where we're going. And when it talks about IFR weather, you're talking about visibility so low that you can't see the ground and you can't use any references from the ground. Okay. So we can see on this pretty little chart here, we can see a trough, we can see a stationary front, we can see some highs and some lows, we can see a cold front, a warm front, right? We can also see the ceilings. These areas have ceilings. And then if we look at this and look at our chart that I gave you guys, we know that that's moderate snow. Okay. These are areas where there's snowfall. If we see two dots, that's areas of rain. If we see this triangle with a rain dot on top of it, that's an area of showers, rain showers. We know that this is fog. Okay. Thunderstorms, right? So the SIGs means ceilings, and then we'll use that chart to decipher what these symbols are. Okay.
Oh, so if the red and like towards the western part of the United States, if the red and blue are mixed in together, how do you know which SIGs are which? Oh, sorry, because VFR, IFR.
Yeah, it doesn't matter if it's reporting ceilings or not. If it's blue, it's marginal VFR, and if it's red, it's IFR weather. Ceilings just means that there's ceilings being reported in that area. As you can tell, is this reporting ceilings in Bozeman, Montana, Coeur d'Alene, Idaho, or Olympia? Don't know. Not identifying a specific airport. It's just saying that there's ceilings in general in this area. So it's this is just giving us a general understanding of what's going on. We know there's no ceilings being reported in the New Mexico, Arizona area, things like that. So this is just a super high level view of what's happening at the surface out there. Okay. TCFs are, we use these for areas of severe weather. So when we talk about TCFs, we use these a lot in dispatching, because those areas of red with the dashed lines, the areas with the dashed lines are basically areas of severe weather, to the point where traffic's being constrained in that area. Basically, so it stands for traffic. What is it? Traffic flow management. Yeah, traffic flow management. Basically, it's convective activity to the point where ATC is routing airplanes around this area. So if I see an area, a TCF area, I just plan on routing my aircraft around that area. This tells us our ceilings. You can see that 340 with an arrow pointing to that area. That's saying the tops of that storm are at 340. Okay. Okay. TCF. Okay. Traffic convective forecast. We'll get there. TFM, traffic flow management. Anyways, Yeah. So with this chart, we can see forecasted out where that storm's going to be. Okay. That's where we just want to plan not to fly. Everybody good with that? Super simple chart. Half the time it says no TCFs published, but when it does, we just want to plan on routing around that.
So like the red mark area, is that the only TCF?
Yep, that's the only TCF.
Okay.
All right, low level significant weather chart. As you can see, a lot of the same information. Hey, look at that. We see an occluded front. Okay, important thing to remember here. We've got a legend, right? See the areas of MVFR, marginal VFR, and IFR. Okay, we also see where the freezing levels are in hundreds of feet. So we can see that it's just basically blocking out an area of the map. These dashed green lines are blocking out an area of the United States. And we can see these little green numbers that tell us what the freezing level is in that area. Freezing level is expected to be around 12,000 feet here. Freezing level is expected to be around 8,000 feet here. 4,000 feet here, at the surface here. Okay. Does that make sense to everybody?
I don't see any green lines. I don't know if we're looking at the same.
Oh, goodness sakes. I got to catch you guys
Sorry.
up.
That's okay.
Yeah, I was just about to say the same thing.
Hold on. I want to get back to where... Oh, okay. My bad. Okay. Anyways, so our low-level significant weather chart here, we can see a lot of those same symbols we saw in the other charts, right? We can see our fronts, we can see our lows, our highs, and we're looking at low level, right? This is a 12-hour forecast. We can extend that out to 24 hours if we would like to. But anyways, we can see this dashed green line. This tells us our freezing levels. It's blocking out that area in the United States. Okay, when it's really close dashed green line like that, that's just saying at the surface. Okay, these longer lines, we can see these green numbers here. Like here, we can see that it's at 8,000, 12,000 feet, 8,000, 4,000 feet. So that's where they're expecting freezing levels. Okay. Okay. Once again, MVFR is in blue, IFR is in red, just like on the other chart. We can see occluded fronts here, low or cold front, warm front, stationary front, occluded front, troughs. We also see the same little symbols that I gave you guys on your chart, you know, areas of snow and fog or rainfall, things like that.
So like the freezing level when it's all dash green going across. I can't tell. I don't know if it's my eyes or if I'm just colorblind. I can't tell if the small green dots versus the big green dots are the same thing, or if that's a yellow.
Is that better? See how close these green dash dots are?
Yeah.
And these ones are longer?
Yeah.
So if it's really close dash dots like that, then we know that the freezing level in that area is 0. So 0 means at the surface. Okay. If we look at our legend down here, we see that it's in hundreds of feet. So 40 times 100, 4,000 feet, 8,000 feet, 12,000 feet. Okay.
So that's going all the way across the.
All the way across.
all the way across the state is at 4,000 feet icing or freezing level.
So if you just follow this line, this is telling us the 4,000 foot freezing level. If you follow this line, this is telling us the 8,000 foot freezing level. If you follow this green line, this is telling us the 12,000 foot freezing level.
Okay.
Okay. So the yellow is turbulence. We can see some symbols down here. If we see one chevron, that's moderate turbulence, and it gives us an altitude. Okay. 18,000 feet, 24,000 to 15,000 feet, 16,000 feet, so on. If we see two chevrons, that's severe turbulence. Okay. That pretty much covers this chart. As you can see, a lot of these charts are identical. Like here we go again, same exact thing. We've got the tan lines of isobars, we've got our fronts, we've got our occluded fronts, troughs, same exact information. Down here, this legend tells us the type of precipitation in the clouds. Okay, rain, mix, and snow. So MSLP, mean sea level pressure, and this is talking about these light tan lines. And this is for surface weather. Okay, here's something new. Winds aloft forecast. Okay, with our winds aloft forecast, we can change the elevation of the forecast. Okay, typically we're flying in the 30,000 foot to 34,000 foot range. So that's where I kind of tend to look, is 34,000 foot, is because most of my flights are going to be conducted at that flight level. So if I'm looking at this 34,000 foot, you can see here in the legend, the white numbers are degrees of Celsius. Okay, so at 34,000 feet, it's negative 60 here, negative 58, negative 57, negative 49, and so on, right? The yellow bars here, talking about these symbols, these, we call them flags, okay? These are our winds. This tells us the general speed of the wind in that area. So at 34,000 feet, we kind of talked about this earlier, we see two big triangles here, two flags on our flagpole. Okay, these bigger flags on our flagpole represent 50 knots each. So each one is 50 knots. So that means we have 100 knots, and then each one of these long bars, long skinny bars, are 10 knots. Okay, so if we add this up, 50 plus 50 plus 10 plus 10, that's 120 knot winds at 34,000 feet over this area. Okay. Who wants to tell me what the winds are right here?
I can.
Okay.
That would be 140.
Yep, 140 knots. Okay, does that make sense to everybody?
Yes.
Okay, now this shorter bar that we see here, can you guys see this shorter bar? That's 5 knots, okay? So if we're looking at like this one, we would go 50 plus 50 plus 10 plus 5. So 115 knots.
So is it only labeled in 50s, 10s, and 5s, nothing else?
Yep. Those are the only symbols you'll see. Okay. Now, which way is what direction? Now that we know the speed of the wind, what direction is the wind heading?
West.
Nope.
Oh, sorry.
I don't know if it's
Southwest.
following the same analogy, but is it like a flagpole where it's blowing across those?
Yeah, so the bottom of our flagpole here, think of it as like an arrow, and this is the fletching of the arrow. This is the feathers on the back of the arrow. Okay? And this is the point. Does that make sense?
So it'd be blowing.
So we're in this region, the winds are coming from the north blowing to the south. Okay? In this region, our winds are blowing from the west to the east. In this region, it's blowing from the southwest to the northeast. Okay? And in this region, once again, we're blowing from the west to the east. This region is doing whatever the crap it wants to do.
Okay, so just so I can understand it better, so like the skinny part of the flag is the direction it's heading, basically.
Yeah, if you just like think of them as arrows.
Okay.
You can see. Can you see that?
Yeah.
Like the fletching on the arrow, the feathers on the back of the arrow. Just think of it as a bunch of arrows.
And that makes sense because that makes sense because I've heard a lot of stories how it usually takes at least 6.5 or so hours to get from New York to LA and less time if you're going the opposite direction.
Yeah, so
I've heard that a whole bunch of times.
So that's due to, do we have a headwind or tailwind? You know,
tailwind.
And in this map, we would have a tailwind from LA to New York pretty much the whole way. Okay. Now, this is also telling us our wind contour. Okay, this is basically taking all these flags in this area and just kind of saying, hey, this lighter blue area, you can just call it 70 knots. Okay, the darker blue area that we see right here, we can just call that 100 knots. This light pink area, magenta, whatever you want to call it, I'm not a girl, so I don't know my colors very well. This is 130 knots. Okay, and this area right here would be 160 knots. So looking at the general winds, what can we say about this as far as like, you know, areas of high wind? What do we call that really high wind?
That's the jet stream. It's kind of going right through the country.
Okay, we can see basically the contour of the jet stream. Okay. Looking at this chart, we can tell that the jet stream, the areas of highest winds through the country, running through the country, are going to be in this. So we can just kind of look at this map and go, oh, there's the jet stream. Makes it really easy, right? Okay, that's your winds aloft chart. Okay, what is this?
Your temperature.
Okay, and what's the temperature there?
Negative 49.
Okay. What's this?
30 knots.
30 knots of wind. And what direction is it going?
I'm thinking it's going northeast.
Yep, so it's headed from the southwest to the northeast. Good. And where's the jet stream? Right chair.
And would that be the tropical?
Tropical is going to be down lower. You can see kind of the edge of the tropical. Okay. Good observation. Okay. We have a polar and a tropical jet stream, right?
Yeah, I wouldn't think it would be polar. I thought polar would be higher up, but I'm wrong.
So if you remember the bands, I wish I could zoom out of this map, but there's bands of, like this would be like the tropical band. This would be the polar band up here. And in between those two bands or air masses, so this one tends to spin this way. This one tends to spin this way, right? So this one's spinning this way, this one's spinning this way. The jet stream lies between the two bands, right? So good observation. Severe weather outlook. This is just giving us an outlook on where the thunderstorm's going to probably be. Are there going to be heavy thunderstorms? Is there a good chance, a poor chance? And hold on.
I like this map. It doesn't give me a headache.
Okay. Looking at this map, the color shaded areas will give us different probabilities. Okay, these are our probabilities. Okay, what it's saying is that this area here, this green area here, there is a mild chance that there's going to be thunderstorms. Okay, now if it was this shade of green, it would be a marginal chance. If it was this shade, it'd be a yellow. If it was this shade, it'd be, I don't know what ENH stands for. If it was red, it'd be moderate, and purple is high. Okay, sometimes on this chart, we'll see rings as well. We'll see these white rings here. Let me see. Oh boy. Won't let me choose my custom color. Anyways, you'll see these like rings. You'll see like a 20 in here. You'll see another ring that's like 10. You'll see a really tiny ring right here that says like 40 next to it. Anyways, those are the percentages that there will be a severe thunderstorm in that area.
A severe thunderstorm, or like within that.
Exactly.
Like if it's circles, what was that?
Exactly what I said. A severe thunderstorm in that area. Okay, it can be green, and that just means that there's a marginal chance that we're going to have thunderstorms in this general area. Okay, that just means that somewhere in this area over the next, let's see how far this outlook is. I think it's 12 hours. Somewhere or sometime in the next 12 hours, there is a mild chance that we're going to see thunderstorms somewhere in this block. Okay. Now, if there was another block with this lighter green color, then it would be marginal. But when I'm talking about the rings, they're like a white ring. Okay. It would be like a white ring in here, and it would say 20 or some number, and that would be the percentage of chance that it would be a severe thunderstorm. It's hard to explain it without seeing it.
Oh no, I understand.
Oh, so that was 48 hours. So sometime in the next 48 hours, then it was that bigger blob. Sometime in the next 24 hours, we'll see this area or this area, there's a mild chance that we'll see thunderstorms in those areas.
Garrett, just a point of interest on the reading these colors. It was watching that disaster down in Texas with the storms, and they're kind of hyping up all the damage and need to evacuate ahead of the storm, and so someone did a survey on where they thought it would do the most damage, and these are people that were supposed to know, and none of them got it right because they always show this big red nasty looking chunk of red, and they believed that that was the speed of the winds, but it's actually the temperature and had nothing to do with so much the speed and the damage. It was just the temperature.
Yeah. It's easy to get these things mixed up, these maps mixed up. But this is what I'm talking about. So that first one was severe weather, just talking about some sort of severe weather. This one's talking about thunderstorm probability. Okay. So as you can see, there's a color scale that's telling us a percentage. And then there's these bands that are saying like there's a 40% that it'll be severe thunderstorm in this band. It's a 60% chance that there will be a severe thunderstorm in this band.
So are you still in that same grid you just turned something else on?
Nope. This is a separate chart. So that first one was just severe weather. This is the thunderstorm probability chart. See, I mixed up the maps. Not good. There goes Houston. So 10% chance of severe thunderstorms somewhere in this area, 20% in this area, 40% that it's going to be in this area, 40, 50, 60. 60% chance that Dallas is going to be in deep trouble sometime within the next 12 hours. Right when I'm supposed to be at work. Yay! Another day of dealing with Dallas. Okay, high level significant weather changes up the view a little bit, but the important thing to remember is you can always look down here, and this gives us an idea of what it's talking about. Okay, jet stream, there you go. Turbulence, it's going to be somewhere in here. Okay. Cumulonimbus areas, volcanic oh my goodness, volcanic ash areas, areas of radiation. I mean, if we were looking over Russia right now, all we'd see is this in North Korea, right? If there were tropical storms, let's see. That's pretty much it. I'll tell you how many times I've actually looked and used this chart. 0. But it's important. I'm a little tired right now, if you guys can't tell. Oh, man. Okay. Upper air analysis is another one that we can take a look at. Once again, this is giving us a flight level. I tend to look at the 34,000 feet. Okay. It tells us that our wind speeds, it's basically regurgitating the same exact information as our weather, our winds aloft chart. It's just doing it in a different way. And that's what you're going to see in every one of these charts, is it's the same exact information at a different level or just in a different format, but identical. You're still pulling the same exact information off. So, anyways, that covers our charts. We don't really care about the rest of them. Does anybody have any questions on any of the charts? Want me to go back and take a look at them? Anything like that?
I might print these out.
Yeah. Just rewatch this video. I mean, we've only spent like 30 minutes covering these charts. So it's not going to like, you can fast forward if you have a question on a certain chart. You can kind of fast forward to that chart and just get some of the information we talked about. If you want to, just use aviationweather.gov. If you guys want to practice looking at these charts and kind of picking them apart, pull them up on Aviation Weather. And if you have any questions on them, you can talk to me or Adam. You can use this website that I put in here. If I can get it to work. Just pull it up in here. Boom. That'll give us symbols, things like that. Cool beans. You guys want to see where SkyWest flies? I think I pulled this map up before. These are our daily flights.
Nice.
Not to mention, some of those flights will do 4, 5, 6 times a day. So
I never thought SkyWest reached all the way out to Las Vegas.
what do you mean? We're international, baby. We are the largest regional airline.
Because like I would always go plane spotting at that little fence at McCarran on Sunset Boulevard, and I've been there for at least 5 hours at one point, and I've never seen the SkyWest land during those 5 hours.
You've never seen a CRJ or a Brasilia
I really have not seen a Brasilia or a CRJ that has like I see them now, but well, actually no, that doesn't make any sense. But back in the day, I guess I would say I haven't seen them like at all. But I've only seen them fly there for like the past couple of years, maybe. I don't know if they've been flying longer than that to that destination.
Long time. West Coast has been our bread and butter. We're getting a lot more of these East Coast routes. LaGuardia, we're about to pick up a whole crap ton of LaGuardia flights. So,
yeah. And I know you guys used to have. Well, I know you guys used to have flights from St. George to Vegas. I don't know why they canceled that.
Not profitable.
Oh yeah, I guess it makes sense.
The only flights I know that are out of St. George for SkyWest are, and they're operated under different carriers, but St. George to Salt Lake, St. George to Denver, St. George to Phoenix, St. George to Los Angeles. The one to Salt Lake is our Delta. The one to Denver and Los Angeles are United, and the one to Phoenix is American. So
interesting in talking to some of the people at SkyWest in marketing. They've really taken a lot of hits as of late on the departures and pushback, cancellations, all that, since they've been taking all the East Coast flying. Some of the rougher schedules in terms of weather.
Yeah, LaGuardia sucks. Ugh. But hey, it's business. West Coast flying, we love it. Except for San Francisco. Other than that, we can deal with the rest. But yeah, kind of fun to look at. That's a lot. If you look at like our first couple maps, like our first map was like St. George or Cedar City, Salt Lake. That was it. And it cost, what was it? It was like $1 or a penny per pound. Is what the advertisement was, something like that. 10 cents a pound. I can't remember. Something like that. It's like $20 to fly to Salt Lake. Anyways, good times. Any other questions? Not that I answered a question there.
Trying to think. I'll have to come up with it another day and ask you.
All right. So, METAR's there for you guys to practice on. Knock these suckers out. What I want you to do, don't edit the document on the Google Drive, because then nobody else gets to edit. Nobody else gets to play. So print out the document here and do it that way. Or you can go to File here and you can go to Download as Microsoft Word document, plain text, whatever you want to do. Download it to your computer, then play with it. But don't play with it on the Google Drive because it'll mess it up. Mess up the fun for everybody else. So, all right, let's call it a night. Good job tonight. You guys are getting one of the biggest. You guys are starting to understand probably the biggest, most important thing that we do as dispatchers. So pat yourselves on the back. It's a pretty important thing. Other than that, we'll see you guys tomorrow. Yeah. I beat you guys up pretty good tonight.
Good luck. No, good luck with Dallas.
Thank you. All right,
Thank
guys.
you.
Yep.
Thanks, Garrett.
No problem.